Hello and welcome to this tutorial. I will show you how you create your own functional equations based on such a data table. The results will look like these sheets, and in the end you will also have a nice overview where all information is summarized. In order to get started, you just need the property table or such a data table, and that's more or less it. I will show you now how we do this by just deleting all the other stuff so that you get an idea how quickly the program works. The program is an own creation, it's called FunctionFinder, and I will show you how this goes. You start this by using a shortcut, and we have to switch to the English version. Then we just read in the x values and the y values. Then we go to auto functions and we get a summary of or a list of functions that we may use, and what's also quite handy is that you see the maximum deviations in both directions immediately. And in this case I will go for the line. I select the function, I see the new calculated values immediately in the list, as well as the deviation. In the next step I will create a diagram with a click. The labeling of the diagram is automatically done by the program. I take over the data and the diagram is created in the background. I can now go to Excel, look into the information section. I will see the current function, the function type, the parameters, the data, the list with all the datas as well, and a copy block which I could immediately take and copy to another cell or to another file, and if I enter a value here, the result is immediately calculated. There's also a copy block where you can, for example, take this summarized cell and put it into a document or an email to send it over and to use it in some other document where you have the equation as well as the units included in one cell. What's also handy is that you can change the numbers on the screen immediately. So if the numbers are too complex or too many decimal digits, you can immediately change those. And you see the result and the deviations also directly on the screen. So if I take, for example, 2, then you see the deviations will increase. Anyway, to get all these changes redone, I simply created new, and that's it. Then we just go on and we take the next value, which is the density. We simply read in the y values again, the x values have not changed. I say OK, and I use auto functions again, and I guess I go for the line again. I select this, hit on the chart button, take over the information, and we have a look, and oops, this seems to be a typo in the original data, because the red one is the original data, the blue one is the calculated function values, and I guess it's, we just have a look, it's the point at 20 degrees C. So I assume that this one is a typo. Maybe it's 178. Maybe it's more like 188. So this looks much better, so I guess this is simply wrong in the original data, and you see that the line fits perfectly as the deviation, the size of deviation has decreased significantly. So we're done with the density. We go on. We go for the thermal conductivity. We simply read in the new values, use auto functions, and I guess the line would be the perfect choice. But I can also show you how this works. If we take a more complicated one, it doesn't make sense just to this small percentage of less deviation to choose such function. But anyway, we simply create the one. We go to Excel. Okay, I see that the original data has some ups and downs, so this is the reason why the deviation is a little bit higher, even with a quite complex function. And you can see that the function is rather long. So this is nothing that you would like to type in manually. So copying this one or copying the complete block is quite nice. And by using these polynomials, it's always some sort of risky, because you never know how the function behaves outside the range. Therefore, there's a nice option. It's called forecast left and forecast right. And by using this, the data range is simply extended to the left and to the right, and you can see how the function develops and behaves, and so you can make a better selection whether this is useful or not. I guess we don't need this anymore. I simply delete that. Then we just continue. Which one's next? I don't know. We just have a look. We go back. It's the kinematic viscosity. We go to auto functions again. And this time, this is the first time where the deviations and also the R² values are rather high. We can go for the best option and still see that the deviations are significant. We simply use this, and I guess that's not, the forecast is not required for this function type anymore. Well, anyway, we just go ahead and have a look. We look to the new function and we see that this is going up and down. So this is something that I wouldn't use in a technical calculation. Furthermore, there's the risk where how the curve behaves way there and on the left side here. So for this type of properties, so for the viscosity and for the vapor pressure, it's much better to use a built-in function, which is not included in Excel or in other programs as easy. So we just take this equation and just make it make a known calculation which has about 16 million runs, but you saw that the running time is rather small, so it doesn't really matter. We have a first look, and this does not look too bad, I would say. In order to get maybe a little bit closer, especially here when we see now that the curve looks quite nice. So the function values are more or less, they look like they are very close to the original values. And if we look to the data table here, we see that we have -20%, -22. So this is not too bad, but I guess for some applications this might not be the right choice, and we can see what we can do else. And there's another option, it's called tolerance corridor. When we use this one, we simply go to automatic calculations, where the program tries to iterate for the best solution, and we start with ±100%, and we see what comes out. We do not care for the parameters, we simply go with the basic data, and we see that the result seems to be much better than before. It's ±3 in a few percent. Here are the maximum numbers, and we just have a look to the chart itself. It doesn't look too different from before, but right now the parameters are set that the maximum deviations are just between 3.27 and -3.12%, which is much more precise, and for most technical calculations I would say this is an equation I would going to use. The first two equations, we can delete those later on, and yeah, we just go ahead, and I think there's just one last property missing. It's the vapor pressure. We can use the auto functions, but by the way, there are too many values here. I simply start again. I close the program, so all the values are gone. I simply read them in now, so that we do not have too much data here that is not belonging to this property. And we go to the auto functions, and here we already see that this is also not maybe the best choice. However, this looks quite close. We can have a try here. Looks fine. This is not too bad, especially because the big deviations are in the starting area, where the absolute deviations are rather small, while at the end the deviations are much less. Nevertheless, I wouldn't go for a polynomial of the 8th degree in this case, because usually an exponential function suits much better. We calculate again. This is the wrong one. Take 410. This is a standard type. Now it calculates a little bit longer. Now we are done. And right now we can go and maybe we can also change the parameters manually in order to reduce the number of calculations and to speed up the overall process a little bit. And we go to the tolerance corridor and the automatic calculations again. Simply hit the start button and we look where we can go. -20 plus 10%. Let's have a look how the chart looks like. Well, I guess maybe we should try the optimize approximation. Maybe this is better. In order not to have it run for one day, I simply reset it and simply start it again. Sometimes these numbers are misleading when you change the function, so don't worry, it will just be a few seconds. And then we also change some parameters manually in order to reduce the number of calculations and just go for the automatic iteration. Okay, we haven't come too close. Let's have a look how the function or the chart looks like. Well, in the end I would say this, at least it looks fine. If we have a closer look to the values itself, then we see that it starts at around 160 degrees, that the deviation raises in percentage. The question is, how important is that? Because usually I guess it's more important to focus on the latter section, but this is something that you have to decide as the user what you are looking for, and then you can see which approach would be best. Now that we have created all functions, we can go to the overview, and here we see all the functions, all the charts that we have created, and there's a handy hyperlink. So if you would like to have a look to this function here, you can simply go to the hyperlink and go back and see how it goes. And well, I guess this function here, this is not needed. We can simply delete that. So we've got one heat capacity, one density, one conductivity. I think the latest kinematic viscosity was the best, so we simply delete the other ones. And we also go for the latest vapor pressure. And if we just go back to the program and hit this button, it will tidy up the overview. We delete those lines. And this is the complete summary that we have created. We can do it, or we can make it a little bit nicer. But in the end, this is what you can achieve within about 10 minutes. And I guess that was what I wanted to show you, and I hope you enjoyed or what you saw. And if you would like to test the program, please contact me.